Hey everyone, so let's talk about the next step here, the input processing output model. This is at a high level the process that almost all computing follows in some way, shape, or form, or at least all programs. So when you're writing Python to do data analytics, it's going to also look like this. Basically, we always collect some sort of data or input. We perform some formulas or calculations. We also apply formatting. And then we output or return the results back to the user. And there's ways to do each of these things dynamically, meaning these processes can change or be dynamic and adapt to the data or the context that we follow. So in the prior chapter, you've already learned how to do the print command, and that's nothing new. You've also learned how to do some basic processing with mathematical operators. So let's start next by focusing on how to collect inputs using this code right here. So let's go ahead and open up a new document in collab.research.google.com, and this should take you to your, if you're logged in to your Google Colab. I'm going to cancel out of this and I want to create a new Python 3 notebook. And if you're lucky to keep track of these files, let's just rename this one as soon as it opens up. I'm taking its time here. Loading still. All right, there we go. Let's call this one chapter 3.2 and 3.3. We'll do both together at once. So we'll use this to keep track of all of the code samples from the book. So let's start with what you're used to. Let's create a variable. Let's declare a variable. Let's call it, in our example here, we called it name, but I'm not going to use this input yet. I want to show you the difference. So let's make a variable called name. Let's set it equal to whatever your name is. Mark. Let's print back out. Hello. My name is, and then let's add a space. Let's concatenate with the plus sign that variable name. So this is what we did previously, where we printed out and we learned how to do string concatenation. So here's what we want to do. We don't want to have to hard code that name in there. We want this program to be dynamic. We want it to change the output based on the input that it's given. So what we do is we take this variable, and instead of setting equal to a string literal or a value here in quotation marks, we're going to use another Python function called input. Now notice input turned blue as soon as I finish typing it because Python recognizes that that name as a command in the Python library, much like print. So we're going to say what input wants here is a question or text or a prompt that you'll give the user to let them know what it is they're supposed to input. So something like enter your name here. So now when we run this, we get this little pop-up, well, not a pop-up, but an input box, and it says enter your name here, giving the instructions I gave it. So now I type in my name. Notice that this program here is spinning, meaning that the program hasn't finished. It's processed the first line, but it's paused, waiting for feedback from the user before it can process the next line. So that is what indicates that the program is running. So anyway, I'm going to hit enter, and now it's able to take what I gave it and print it back out. All right, that's our input. Not too complicated. Let's see if there's much we want to expand on it. So we can return the type of the input as follows. Let's go back here. I'm going to copy this just to keep track of everything. You don't have to do this. If you don't want to take the time, you can just sit there and edit and work on the same code box. But what I'm going to do next here is I want to input my name, and then I want to print out. Inside here I'm going to put the word type. Type, notice, turns blue because it's another keyword that's reserved by Python. And I'm going to return the type of, not that whole text, but just the variable name. So what type does is it says type accepts an input, and it takes as an input the variable or some sort of data that we can hard code in there, like this text. And it's going to tell us what type of data that variable is, or what type of data that variable is storing. So let's run this. Enter your name here. Put in Mark. Now notice, just because it asks me for a name, well, I'll get that in a minute, but here's the response. It gives it to us in this HTML formatted looking thing with brackets here, and it says the class, meaning the class of or the type of the data of this variable right here, is str string. Now if I were to run this program again, notice that just because I said enter your name here, that doesn't mean I have to enter a name. I can put in the number 9 and it still says string. Why? Because the input command is expecting a string as an input. So when I run this, it's expecting that anything I put in here is going to be a string. Even if I put in 7.1, now I've got a float, it still calls it a string. So if I want to accept something from the user that I don't necessarily want to be a string, I'm going to have to cast it like we learned in the last chapter. So let's do that next. Let's enter your age here. And this time, let's wrap int around the input. So notice this is what we call nesting. Here I'm nesting functions inside of functions. So here the input function says, here's the text to give them. Take whatever they give us back and run it inside of this function. Well, what does this function do? We learned in the last chapter that the int function tries to cast it or convert the data type to an int if it can be converted. Now obviously if they were to enter something that's string, like Mark, it can't cast that into an int. And it's going to give us this value error that says, wait a minute, invalid literal for int with base 10 Mark, meaning we can't convert Mark into an integer. But if I run it again, say enter your age here, it says, okay, class is now int. Whereas before, when we entered 7.1, it said class was string. Now we were able to cast it to an integer. And so now when we print out the type of data that is stored in name, we can see that it's an int. So I want to make sure you follow this. The printing out the type of the variable is different from printing out what's actually in the variable itself. So as I run this, enter your age here, 40. Notice I first printed out what type of variable is that, class int, and then next I printed out the actual value stored in name. So remember, this equal sign is an assignment operator. This says assign to this variable whatever's on the right. Assignment always happens by taking what's on the right and storing that in what's on the left. So what's on the left gets changed to whatever's on the right and not the other way around. So I can't say, whoops, I meant to forget sometimes when I'm on a Mac versus on a PC, I've got to use command instead of control. I need to enter a line down. There we go. Let me try that again. There we go. This doesn't work. So if I put this on the left, it's going to try and change this input box to whatever's stored in age, but it doesn't work that way. This input box is going to ask for a value, and I'm going to set it, but it's not a variable right here. This isn't a variable name, it's a function, it's a command that requests input. So I'll get an error when I try and run this. But just know that we never do it that way. Whenever we want to change or give a variable a value, we always put the variable name on the left. The new value that we want to change it to is on the right. All right. So not bad. Let's go on. Let's see what else we can learn here. So last thing, integer value using the input function. Yeah, we can go ahead and do this. Actually, I'll just copy it here to make it easy so you can see what's going on. Oops. There we go. I don't like these extra tabs it adds in, so I hit Shift Tab to pull it back like that. All right, there we go. Enter a number. We'll put in some number, 40. There we go. You enter the number 40, class int. All right, so that's all for integer values. Let's learn about outputs in the next chapter. I think I'm going to stop this video here and we'll call this 3.2.